feature that allows you to perform advanced data analysis across rows while training row level granularity. And we'll go over key window functions, row number, rank, indents, rank, NTILE, lead and lag, first value and last value over clause. Practical examples, best practices, hands-on challenge, exercises, and the summary. So Windows functions are SQL functions that operate on a set of rows related to the current row. Unlike aggregate functions, they do not collapse rows, but instead add calculated values to each row. Window functions are especially useful for ranking rows, calculating moving averages, retrieving values from other rows, performing cumulative calculations. Row number is a unique sequential integer to rows within a partition. Rank assigns a rank to rows in a partition with gaps in ranking for ties. Dense rank is similar to rank but without gaps in ranking for ties. NTILE divides rows into specified number of groups and assigns each row a group ID. Lead and lag shows retrieve values from the next or previous row in a partition. First value retrieves the first value in a partition. Last value retrieves the last value in a partition. So each Windows function is used with the over clause. So we have select column name, Windows function over, partition by column name, order by column name as alias name from table name. We have practical examples like row number, assign a unique number to each employee within their department, select employee ID, department ID, salary, row number over partition by department ID, order by salary, descending as row number. So it looks like the over function is key here. It's selecting three variables with the row number split up by the department ID. I've actually never seen this partition by function before. And there's order by salary descending, so from highest to smallest as the row number. There's rank and dense rank, so rank employees by salary within their department. Select employee ID, department ID, salary, rank over partition by department ID, order by salary descending as rank from employees. Dense rank is select employee ID, department ID, salary, same thing, except dense rank over partition by department ID, order by salary descending as this. NTILE divide employees into 4 salary quartiles. Select these three things, NTILE 4 over partition by department ID, order by salary. Lead and lag, retrieve the previous and next employee's salary. Select employee ID salary. Lag salary over order by its previous salary. Lead salary over order by its salary is next salary from employees. You have the first value and last value. So get the first and last salary in each department. Select employee ID, department ID, salary. First value salary over partition by department ID, order by salary is min salary. Last value salary over partition by department ID, order by salary rows between unbounded preceding and unbounded following is max salary and from employees. You have an over clause, and this defines the window or set of rows that the Windows function operates on. It can include the following components. Partition by divides the results into partitions. Order by specifies the order of rows within each partition. Rows or range defines the frame of rows for each calculation. Select employee ID, salary, sum salary over partition by department ID, order by salary as this, and then we have best practices. So use partition by wisely, partition data meaningfully to get accurate results, optimize performance, combine window functions with index columns to improve query speed, understand rows versus range, be clear on how the window frame affects calculations, avoid overlapping calculations, reduce redundancy by minimizing the number of window functions in a query. You have a hands-on challenge, which uses row number to identify top 3 earners in each department. Use rank and dense rank to rank employees based on their performance scores. Calculate a running total of sales using a window function. Use lead and lag to compare a product's sales with its previous and next month's performance. Retrieve the first and last transaction amounts for each customer using first value and last value. And there's some exercises. So write a query to assign row numbers to students in each class based on their grades. Rank products by sales revenue within each category. Retrieve the previous and next order amounts for each customer. And you basically divide employees into 3 groups based on their salaries and assign a group ID. Calculate the cumulative sum of sales for each product category. Retrieve the first and last purchase amounts for each region in the sales table. And then this basically goes over a Windows function in SQL, including row number, rank, NTILE, and first value. These tools allow for sophisticated analysis while maintaining row level details. Experiment with combining these functions to unlock powerful insights, and then we can explore common table expressions, which we'll go into, I guess, in the next lesson, and it'll be, I guess, with clause, recursive CTEs, and we'll cover this in maybe the next one, or we can probably quickly go through it now. So, common table expressions in SQL. These are an essential tool for writing clear, modular, and reusable SQL queries. So we'll go over the syntax, examples, practices, and hands-on challenge. So these are temporary result sets that simplify complex queries. They make your SQL code easier to read and maintain by allowing you to build modular queries. So they're especially useful for splitting complex queries into logical steps, creating reusable query components, implementing recursive queries. So with clause basics, the with clause introduces CTEs, the syntax with CT name as select column 1, 2 from table name where condition is this. Select star from CT name with sales summary is select product ID, sum sales amount is total sales, from sales group by product ID. Select star from sales summary where total sales greater than 1,000. We have recursive CTEs which allow query to reference itself. They're commonly used for hierarchical data like organizational charts or tree structures. They basically have recursive CT name as anchor members like column 1, 2 from table name where condition is union all. Select column 1, 2 from table name, inner join CTE name on these tables. I'm trying to understand how to use these common table expressions. It looks like it's using a join. There's also with recursive employee hierarchy as another anchor member, get top level manager, select employee ID, manager ID 1 as level from employees or manager ID is null, union all. Recursive member, get employees reporting to the previous level, select e dot employee ID, e dot manager ID, each level plus 1 from employees E, inner join employee hierarchy on e dot manager ID of this, select star from employee hierarchy, and then we have some practical examples, simplify complex joins. Use CTs to break down multi-step join operations with filtered orders as select order ID, customer ID from orders, where order date is greater than this. Customer summary, select customer ID, count order ID is counter count from filtered orders, group by this. Select star from customer summary, where order count is greater than 5. Generate running totals with running total as select order ID, customer ID, order date, sum order amount over partition by customer ID, order by order date as cumulative sales from orders. Select star from running total where cumulative sales greater than 500. Traverse hierarchical data with recursive org chart as this. Select employee ID, manager ID as 0 as level from employees or manager ID is null. Union all. Select the e.employee ID, e.manager ID, OC.level plus 1 from employees, inner join, and there's some best practices. So use descriptive names, name your CTs clearly to reflect their purpose. Limit scope, avoid overly large or complex CTs, keep them focused, optimize for performance, use index columns, and avoid unnecessary computations within the CTE. Test recursion for recursive CTs, ensure there's a termination condition to avoid infinite loops. There's a hands-on challenge, create a CT to calculate the average sales for each product category and filter categories with above average sales. Use the recursive CT to display a company's organizational hierarchy, implement a CT to find customers with more than 3 orders. Basically, write a query using the CT to list all employees, create a CT to calculate total revenue, and this basically goes over how to simplify complex queries and basic and recursive CTs, practical applications, best practices, and you can make SQL queries more modular, readable, and powerful. And thanks for listening.